For light equations, we have two different equations that we can use. We have the speed of light is equal to 2.998 times 10 to the 8th meters per second, and that light is equal to wavelength times frequency. Then we also have that energy is equal to Planck's constant times frequency, where Planck's constant is equal to 6.626 times 10 to the negative 34 joule seconds. So we have our frequency, and that has units of inverse seconds. We have our wavelength, and that usually has units of nanometers. We need to convert nanometers to meters. There is 10 to the 9th nanometers in every 1 meter. So, if I give you a question, and my question says that your wavelength of light is equal to 625 nanometers, and I want you to find the frequency. I have an equation where my speed of light is equal to wavelength times frequency. I have wavelength, I know my speed of light, and I'm going to solve for frequency. Remembering that my speed of light is equal to 2.998 times 10 to the 8th meters per second. Again, this is in meters per second, so I need to convert my nanometers to meters. So I have 625 nanometers times 10 to the 9th nanometers for every 1 meter, which gives me 625 times 10 to the 9th negative 9 meters. So, knowing that, again, I have my speed of light is equal to wavelength times frequency. I multiply both sides by 1 over frequency, or 1 over wavelength. So you get speed of light over wavelength is equal to frequency. I plug in what I've been given, my 2.998 times 10 to the 8th meters per second over my frequency, or over my wavelength, which is 625 times 10 to the negative 9th meters, and I get as an answer 4.80 times 10 to the 14th inverse seconds. My inverse seconds came from my meters per second divided by meters, or multiplied by 1 over meters. My meters canceled out, I'm left with 1 over seconds. This makes sense because inverse seconds is my unit for frequency. So then I can go on knowing that I have my frequency equal to 4.80 times 10 to the negative, to the positive 14 inverse seconds. I can now go on to find my energy for that wavelength of light. Energy is equal to Planck's constant times frequency, and Planck's constant is equal to 6.626 times 10 to the negative 34 joule seconds. Knowing my Planck's constant, knowing my frequency, I just plug both in, so I get energy is equal to 6.626 times 10 to the negative 34 times my joule seconds times 4.80 times 10 to the 14th inverse seconds. This gives me an energy equal to 3.18 times 10 to the negative 19th joules. Remember that energy is in joules, and that came from having joules per second times 1 over seconds. So my seconds cancel out, and I'm left with joules. So this was an example of being given wavelength, first solving for frequency, and then taking that frequency, solving for energy.